how does amplitude affect wave speed? Amplitude, wave speed, wavelength, they're all kind of tricky subjects to really understand. And if you're like me, you can't really understand them from a pure explanation. You actually need a visual example or something like that. So I'm making this video in order to help people understand these concepts, and we're gonna see if amplitude has any effect on wave speed at all. I doubt it, but I could be proven wrong. We'll see right now. Okay, so before we start with the actual experiment, I'm gonna define a couple of key terms that'll be present throughout the video. That's really to just review them for those of you who already know these terms and what they mean, or to introduce them to the people who are new to them. So we'll start with amplitude. Amplitude is the height of a wave, and that's taken by measuring from the initial point where the wave started and up to the crest of the actual wave that forms. Okay, so the next term is wave speed. Wave speed is just how fast the wave travels. That's the actual term to describe the speed of a wave, and that's taken by dividing the total distance that the wave traveled by time. Wavelength. This one's pretty self-explanatory. It's the length of a wave. That's determined by measuring from the top of one crest to the other crest in the wave that forms. In this case though, wavelength is going to be the same as the total distance traveled. Finally, distance. Distance just describes how far something will travel. In this case, we will be using distance to find wave speed by dividing it by time. And that will be our wave speed. Okay, let's get started. Okay, before I actually get started, I'm going to just make a quick list of my materials. As you'll see later on in the video, some of these things I didn't really use for the experiment. They were just more for me to keep the data in order and all this and that. So what I did use were a slinky, rope, timer, the tape, the metal clamp, and the meter stick. Okay, now before I actually conduct the actual experiment, I'm going to go through my procedure with you guys a little. The first thing I did was obtain my materials. Duh. Okay, second step, I attached one end of the slinky to the metal clamp. And then I screwed on this clamp to a sturdy metal pole. In my case, I was at a school, so I used that metal pole that connects two doors together in the hallways. From there, I tied the rope to the opposite of the end of the slinky, the one that wasn't attached to the clamp, and then I measured out the distance that I wanted the wave to travel. That will be constant, and that will be represented by D in your formula and in your data table. From there, I measured out the desired amplitudes that I wanted the wave to go up to. Those will not be constant. Those will have to change with each trial, and you'll see right now. Okay. Once I got done with all the pre-measurements, I pulled the slinky out to the desired distance that I wanted it to travel. Again, remember, it should be constant. From there, I shook the rope to cause a wave, and as soon as the wave began to travel, I started the timer. When the wave reached the opposite end, I would stop it. Remember to stop it when it reaches the opposite end, because sometimes it recoils and then it comes back to you. It just depends how much, I guess, force you put into the actual movement of the wave. From there, I just recorded the time that it took to reach the opposite end, along with my amplitude and my distance. Okay, after I got done with the first trial, I repeated steps 7 through 9 for 2 more trials. I only did 3 trials in my experiment. You can feel free to do however many you want. Just remember to change the amplitude for each trial. After the whole experiment was done, I calculated the speed of each wave using the formula S equals D over T. S is speed. That's the speed of the wave. That's measured in meters per second. D is the distance, the total distance the wave had to travel. That's measured in meters. And T That's just time. Once again, the time it takes to reach my end to the opposite end, that was measured in seconds. Okay, now I'm about to show you guys the actual experiment. Okay, so this is just to show you guys how I had my experiment set up. I know the explanation of the procedure was a little rocky and hard to understand. So, yeah, this is just a quick glance at how I had it set up. Okay, this is after I measured out my desired amplitudes. Once again, I know the explanation was probably a little rocky. So as you can see, I had it at 10, 20, and 30. And then, this is just the setup of the slinky and how I was going to do it. And here's to show you guys that I actually measured out to 2 meters each time. Okay, so let's get started with the experiment. Okay, so as you can see, the speed did change throughout each trial. Um, I guess you could say the amplitude did have somewhat of an effect on the speed, but the effect wasn't that much since the speed is still within the 6 to 7 meters per second range. So as you can see, each time that the amplitude of a wave increases, the speed decreases. So that means that the higher the amplitude, the longer it takes the wave to reach the end of, the longer it takes for a wave to complete one cycle, one wave, whatever you want to call it. So to conclude, yes, amplitude does have an effect on wave speed. If the amplitude is low, so if the pulse that you project toward the wave is a low pulse and it causes a small amplitude, then the wave will travel faster. But if you cause a pulse that produces a high amplitude, then the wave will travel slower. So yeah, I hope that helps, and that's it.